Hi, my name is Sahas Kulasekara. I am a software engineer undergraduate from Information Institute of Technology. So in this video, I am going to explain my final year initial prototype implementation. So first, I am going to explain my problem background. The skin is the body's outcome layer, and it is a frequently exposed of the elements including dust, pollutions, microorganisms, and UV radiations. Those may be the cause of any type of skin. The skin related disease are also uh, caused by genetic instinct, making skin disease more complex. It mostly commonly appears on the sun exposed skins. However, this common type of skin cancer also can develop in an area of your skin that are not normally exposed to sunlight. Limited or avoid expose to ultraviolet radiation to reduce your skin cancer. In this world have three type of significant skin cancer diseases. So in this proposal I am trying to detect melanoma skin cancer. Melanoma skin cancer is the most dangerous skin cancer among the type of that skin cancers. It is possible to cure it through long-term treatment methods, and if it is discovered in the early stage. But if it is not discovered in the early stage, it will spread the whole skin and the other parts of the body, and you will die. Due to the presence of melanoma in our body, there is a possibility of developing this dangerous disease by exposing to UV rays. Melanoma skin disease are a common problem in a modern society that people tend to ignore them due to a lack of knowledge, busy work life, financial status, and being embarrassed to talk about it. People pay attention to the disease when it's reached to the point when they can no longer ignore it when must contact dermatologist for medical supports. Malignant melanoma is the one of the most deadly and dangerous stage of this cancer. Even though it found the only 4% of the population it is affected by this. It's hold for 75 of death cause due to skin cancer. Most of the time, curing the disease takes a significant amount of time and your money. Now, there have been many research and conducted identification skin cancer using image processing, but it is having been limited to medical center. In this project I am planning to implementation the system for the users to advance identify where they are or he has the skin cancer of this melanoma type, and give a proper knowledge about this skin cancer, and give healthy tips for this. So if we move to the implementation part of this prototype, you can see I'm using the 2.3.0 TensorFlow version for this uh, model. So in the first line, the code import I import two classes for this code from TensorFlow library. It's config proto and interactive sessions. Config proto is used to specify the configuration setting for TensorFlow session. Interactive session is used to create an interactive TensorFlow session. An interactive session makes it easier to work with TensorFlow, as you can run operation and evaluation tens without having a manually manage a session. In this code, I mean, you can see those 0.5 value. So in this code I'm only use half of my GPU memory and limited the growth till 5%. So in the next part in here I import the image generator, and image generator is a utility class in the Keras deep learning framework that is used to perform data augmentation in image data during model training. Data augmentation is a technique used to artificially expand the size of the training dataset by generating new, uh, slightly modified version of the original data. This can help reduce overfitting and improve model performance. So the third part is the version of my TensorFlow that I use. The next part is this is a image generator. So I'm apply data augmentation technique here. Here you can see rescaling value, share range, zoom range, horizontal flip like techniques I'm applied. I've just talk from it from Keras. Okay, in that part, and I'm just reading the training data sets. In here, my target size is 64 cross 64, batch size is 32, and class mode is binary. The reason of the that is I had two class. So if I had a multiple class, I use a categorical, not using binary. So in in this image, you can see there's a sample data set. So I'm using 2649 training data sets and 2257 text image for this model. So and after I'm import two layers, which is con 2D and dense layer. This is for image classification. I'm creating plain neural network for this model. Both convolutional layer and dense layer are fundamental building blocks in neural network architecture. In conv 2D layer is useful for extracting special features from the image data, which dense layer is used to generate learning tasks and can be used to combine with the other type of layers and build more complex neural network architecture. So in this I'm import the regularizers in line 8. So I create the CNN layers in this parts. So in first I'm adding the sequential layer, and I'm adding conv 2D layer with filter 32, padding same, kernel size is 3, activity vision function relu, and the other stuff. So after I'm adding the max pole layer. So max pole 2D layer, because in the CNN we add conv 2D and max pole 2D if it is a normal image. Then after I'm adding those two again for my again in this part you can see in this area I'm using I'm import the L2 regularization. So L2 regularization is commonly used in a variety of machine learning and deep learning models, including linear regularization, logistic regularization, and neural networks. It is a simple and effective way to improve the generalization performance of the model, and it is often used in combination with other regularization techniques. This is a linear SVM for binary classification. So in here you can see the exactly same layer which I will discuss in the last layer, but in this we have two categories, and actional function is softmax. So you can see softmax action function. So is this we use this for multi-classification. So in the CNN summary you can see my entire information about the CNN layers, outputs, shapes, like that. So you can give a brief idea about the summary page about this model. so in this area, uh, I'll compile it. When you doing the compiles, first you have to use optimizer. The import part was is we use the loss function. So in this we use the loss function and optimization. You can see uh, has a hinge at this time is basically going to as SVM. If we add regularization and loss parameter, automatically out final layer will become as SVM layer. After that I'm filtering on my training set validation data and echoes. I'm valid this for 35 echoes. Echoes. So you can see this is my training process. uh, uh, so yeah, I as you can see, I use demo datasets for this now. The actual the accuracy of this model is you can see the 51, and the valuation accuracy is 47. So that's minimum low, because there's a single data set. So I intend to increase it more than a 6 time in current size, so it will be not a problem in future. So after that, so, I wrote that plot for display a loss and accuracy during the model training process. The history of the loss and accuracy in that project is R object, that training process. After that, I got the graph which represent the accuracy and the loss training and validation process. So you can see in this chart in my code, and I saved the model. So those are the functions that I use, and this is the implementation of my model. I'm trying to improve this model and build a Flutter application for detecting a melanoma skin detect for my final year project. Thank you.